Well, that was such a great speech. I'm not sure that you really need me to do another one. So what I thought I'll do is talk a little bit about the place of probability-based internet panels in the whole landscape of survey and other data use and data collection that we're doing. It's mainly to make us all feel good about what we're doing here. It's so that's really the theme of the next couple of slides I want to talk about, really the current landscape of social science data collection and how we use it. So there's a number of different tags to this, a number of different approaches to collecting data. And of course, the first time-honored are the traditional high-quality population studies. And they have a number of really great features. One of them, they all have well-defined sampling frames. They have high response rates. There's major effort put into keeping the response rates up, although they are declining, part of a global declining trend, really. They typically have infrequent data collection, somewhere between mostly 1 and 5 years. Many of the major surveys in the United States have the two-year periodicity. The result is then that if you have these surveys once every couple of years, then you try to cram in as much information in that as possible. But of course, there is a limit to how much you can torture a respondent to give your answer. So that restrains the amount of information that one can collect in these surveys. The interview modes, they started, I guess, most of them with face-to-face, and then phone came in, and then postal surveys have always been part of it, and increasingly internet is part of the toolkit that's being used. And then new data types get added regularly, including particularly biomarkers. Most of the major surveys have some sort of biomarker collection, including sometimes genotyping and all that. And then I just mentioned a couple of examples, but there are more, and I think you probably all know the major surveys that have been, like GSS. I didn't mention GSS, but that's another one, has been around for a long time, and is one of the major surveys. And then, of course, sort of at the other side of the spectrum, there are the convenience internet panels, and they have a number of characteristics that we're familiar with. First of all, they have unknown sampling properties. You don't really know where the sample is coming from. There is a pretty high likelihood, and I think that's one of the issues that you see if people write about is that respondents have a tendency to misrepresent themselves because they try to guess from early questions what the chances are that they will get follow-up questions. So they tend to endorse all sort of conditions, hoping that will then get them to the next part of the survey. And so there's an example that I mentioned here. That's a project out of RAND and UCLA where they used MTurk, and then they asked people about health condition. They want to ask questions about health condition, but they included 2 fake conditions. And it turned out that 15% of the sample endorsed at least one of these 2 fake conditions. Now, there's more to that because they then, 3 months later, re-interviewed a subsample, but a subsample of only people who had not endorsed a fake condition. So these were the good respondents. And then, of course, sure enough, there were still quite a few people who then endorsed the fake conditions. But by having 2 waves, you can actually calculate what the probably the percentages of respondents who would endorse fake conditions if you keep doing it, and it's about 25%. So now you have 25% of the respondents who are not reliable in what they tell you. And of course, there are other aspects, and there's a fairly big literature on this. Now, of course, it's a little unfair to equate convenience internet panels with MTurk, because of course there are many other ones, and there's certainly variation in the quality. But I think there's still a general notion, and really John Krosnick, who's here, has done a lot of work on that, that shows that if you try to generalize to the population, you often are biased in sort of irreparable ways. So reweighting and all that doesn't really help. And I think that still seems to be a defining characteristic. It's really difficult to get population numbers out of these convenience panels. And there is a dramatic example that I think many of you are familiar with because it made quite a stir, which is this paper in Nature that came out, I guess, a year ago or so, where they look at some of the convenience panels that were conducted during the COVID pandemic. And one of them was the Facebook survey that had 250,000 observations every week. And in this case, there is a population benchmark because you can look at vaccination rates, and they asked about vaccination in the Facebook survey. And so what you get with 250,000 is that you get very accurate estimates of the wrong number. And I think they're off, like in May 2021, they were off by about 17 percentage points. So they look at, and you can look at mean squared error, which is sort of a traditional way of looking at the quality of an estimate. So what you get is, and the mean squared error has two components, right? One is just variance, uncertainty, if you like, and the other one is bias. So the bias is big, and then the variance is pretty much zero. But then they ask the question, okay, what kind of random sample of the US population would you need to get the same mean squared error? And the answer is 10, right? So a sample of 10 Americans give you the same mean squared error as 250,000 Facebook respondents. And it's in some ways presenting it like this is probably unfair, because of course there are other reasons why you do that. You want to look at geographic variation. So I'm sure there's a lot of value, but it does tell you that there are issues with relying on panels or surveys where you don't really know the sampling properties. Okay, so then another part of the landscape is big data, which increasingly, of course, becomes an important source of information in the public discourse and generally in trying to understand what's going on in society. And there's a number of characteristics of that. So first of all, their coverage is typically incomplete. You grab whatever you find. You can think of Google Trends, or Facebook in some ways is an example. And there's all sort of other data that you can collect, but most of the time it will not cover everyone, right? It will cover subsets for which it's easy to generate information, and whether that subset is representative for something else, that is always something that's up for debate. And then access to the data may be uneven depending on the company that's producing it, the kind of condition that they impose when you try to use it. And also access may change over time, as people have found to their own detriment that they thought they had this great access and this great data set, and then suddenly they cut off and now they cannot use it anymore. And then there are sensor data, for example, air quality data, traffic data. And also there, first of all, the coverage will vary by topic. For example, we're working with a group doing traffic data in LA, but it turns out, and they use these coils in the pavement, so they, you have these sensors. But then the sensors, there are a lot of them on the freeway, not too many outside the freeway, and then also it varies by which part of the city. So some parts of the city have very few, other parts have bigger. So what you do, so then you get these holes, but the holes are systematic. Certain parts of the city are just not represented very well. And then, of course, the general issue there is also that now you have these data, but often if you want to do analysis, you want to relate it to something else. You want to relate it to individuals. You want to relate it to characteristics of individuals, and that is often problematic to do. And then the company data, which sort of are in a class of their own, and certainly economists have worked with company data a fair bit. Sometimes they can do amazing research, but there they also find out from one day to the next they cut out. And for example, we had a project a number of years ago with someone who was going to do an experiment within a company, and then it sort of got difficult and got postponed. And at the end of the day, it didn't happen. And this happens pretty often. And of course, the other problem is that if access is sort of personalized, you're the one who has the contacts and you work with the company, then no one else has it. So that means that replicability gets squeezed. And replicability, as we have all learned over the years, is very important, because there's so many results that, as often the result is just honest mistake, and it's really important that we can replicate what's being done. So I think there's all these. So big data are great. I've only said negative things about it. They're actually great, but there are also clear downsides that you have to be aware of. And then they have administrative data, and their access is often limited, but really for good reasons, because that's where you want to protect the confidentiality of the people who are in these administrative databases. So access is pretty complicated. But on the other hand, once you have it, and we know, right, we have the data centers, we have all sort of enclaves, they're actually very powerful, because now you can combine survey data with administrative data. And I think that's something there's still a lot to be done. I think it's very promising. It's also a case where the US is way behind, for example, Northern Europe. Well, Scandinavia has a much better structure for accessing the data, and is much more generous in allowing access to that. But this certainly, I think, is important and promising also going forward. So then getting to the probability-based internet panels, I think they certainly share, of course, the reason why they're called probability-based is they share the characteristics of the traditional surveys of having well-defined sampling frames. The response rates are typically way below the traditional population surveys, and that has to do with the cost of doing it and the way the investment in recruiting respondents. So the response rates and then therefore the percent of the population that you represent in some ways is quite a bit lower. But sort of surprisingly, and that's again John Krosnick, but also we've also done some work, is that they still do a good job in representing population parameters. And frankly, I don't understand why, but I do. I mean, that's each time you do. For example, the vaccination example I just mentioned. We also asked it in the US, and we were right on target, right? So and in this Nature article, the other probability-based internet panel was the Ipsos panel was mentioned, and they also did a really good job. So again, I don't quite understand why with relatively low response rates you get a good population representation, but that seems to be sort of a stylized fact almost. And then the attrition rates, frankly, I put a question mark there because it seems. I think the attrition rates tend to be higher than of the traditional surveys, and partly because maybe the amount of effort that's put in traditional surveys is higher. But I put a question mark there because I don't really always know. It's not all of us are equally forthcoming in sort of providing information about the attrition rates on the internet. So I have done some digging, and my sense is that there is some variation, and I think it's higher than in the traditional surveys, but on the other hand, it doesn't seem to be fatal in some ways. So then, of course, finally, so where do we think we're going? And there's some obvious comments we can make. First of all, the phone is becoming problematic, as we all know. It's really hard to get anyone on the phone. I certainly never answer the phone if I don't recognize the number, which really makes my life very easy. Face-to-face is still done and should be done in some cases because there's no alternative, but it's also very expensive. So it really, increasingly, I would think, is something for niche projects more than sort of big population surveys. And then the other thing that we see is more passive data collection, more with wearables. You see this at this point, mostly in convenience samples. So an example is all of us that many of you are familiar with, right? This is this giant survey that's being done. But then, for example, if it comes to information about physical activity, you only sample people already have a Fitbit, for example, right? So you get this self-selection, and people with a Fitbit are certainly different from people without a Fitbit, as an example, right? So at this moment, a lot of that is still in convenience samples, and I think the challenge is to increasingly do this in population representative samples, and people are doing it. Like HRS, I think, is talking about doing more physical activity measurement in the next 6 years. So there's all of that. But I think that's one of the things that's really important to do and to add of all of that. So all of this is, of course, to get us some sense of where we are. Maybe, as I said, make us feel good about probability-based internet panels. And I think we can see this day and a half, where we are in this landscape and what we think our progress is going to be. So I wish you a great day and a half. Thanks.